Let me know when we're live.
I think I muted when I was doing the introduction, but good evening, everyone. My name is Mila. So today we are going to learn about the endocrine system part 11, the bicycle types, which is we're going to learn about ovary and then the ladies cycle. So how exciting is that? So yeah, so I'm so excited to learn more about us and me. So David, over you now.
Well, thank you very much, Mila, and welcome everybody from around the world, and welcome to the bicycle trip. I call it the bicycle trip because we're going to be talking about the two cycles, the ovarian cycle and the menstrual cycle. Okay, and sometimes that bicycle trip can be a bumpy road. So let's have a bit of discussion as we go and see where it leads us. All right, this is Happy Hormones. We've been on this track for some time now. We started out in relationships and we've been through the glands and hormones. We are now in the ovarian and menstrual cycles right here in the bottom here. Our next sessions are in hormones and attraction, creating the mood. Then what is love, intimacy, and then we'll talk about endocrine disrupting chemicals. And then as a teaser, we'll be looking at the lymphatic system next. So this is the endocrine system. This deals with hormones and their glands. So we talked about the glands, the hormones, and what they do. And the reason for that is to allow everyone to have information that's necessary in order to live happy, healthy, and fully throughout their life. And today is the ovarian and menstrual cycles. Now, the endocrine system, again, and to catch anybody up on who has not been here, it's the glands and the hormones they secrete, that is, they give out these hormones. The hormones affect every aspect of our lives. They also are produced at brain, hearts, lungs, liver, skin, the thymus, the gastrointestinal mucosa, the placenta, also produce and release hormones. Hormone is a chemical transmitter, and it is transmitted through the body in the bloodstream. And they go to target organs and the target cells within those organs. Hormones are chemical messengers. So this is a lot slower process than your nervous system. And if you look for the connection between the nervous system and the endocrine system, you'll find it in the hypothalamus in the brain. Now, the hormones produced by the ovaries include estrogen, progesterone, testosterone, the anti-Mullerian hormone, we learned about that last week, inhibin A and inhibin B, and also, as we have learned, and I'll refresh again later, that there is relaxin, which is another hormone that has been identified. Now, relaxin is crucial to the reproductive process. Relaxin is the hormone secreted by the ovary, by the corpus luteum. When a woman is pregnant, the placenta will release the hormones, as will the uterine lining. Relaxin increases after ovulation, where it is believed to relax the wall of the uterus and prepare it for pregnancy. If a woman does not conceive, levels drop until the next cycle. If the woman does conceive, relaxin levels grow through the first trimester, adding aiding in implementation of placenta growth. This hormone also stops contractions as the tiny baby grows to prevent early delivery. Relaxin helps to relax the ligaments in the pelvis to allow it to stretch, assisting in vaginal birth. Other effects have surfaced in recent studies as relaxin peptides have been discovered. Relaxin is proven to lessen tissue fibrosis in many organs and can also promote wound healing. Relaxin also been found to reduce blood pressure by relaxing the blood vessels. This has led to more study into the benefits of relaxin peptide treatment for certain diseases. So talk about what we learned and what we have yet to learn. This is another example of recent scientific discovery associated with the human body. Now, the ovarian cycle is all about ovulation. Ovulation is egg release. Now, to refresh, you have two, in the female, you have two ovaries, one on the left, one on the right of the uterus. The uterus is in the center. This is the vagina in here, okay? This little bit right here is the cervix, and that mucosa forms here to hold the baby in place until birth. Okay, now ovulation is a cycle. It is a 28-day cycle similar to the menstrual cycle. Okay, you start out with follicles. A follicle is essentially the egg in its formative stage. Now, a woman, if you remember from last week, a woman is born with all the eggs she will ever have. Okay, she's born with all the eggs she will ever have, and they're in this follicle stage right in here. And then as time passes coming into ovulation, you have the development of the oocyte, the follicles develop, right? And then they push against the side of the ovary and then are released here. The corpus luteum, was what held the egg in place, then deteriorates. And the corpus luteum generates progesterone, all right, which is to hold the placenta in place should there be a conception. Now, I wanted to include these two slides so that you can have them for reference, because it does show significantly the cycle hormones, luteinizing hormone, LH, follicle stimulating hormone, FSH. You have a follicle phase and you have a luteinal phase of the cycle, both in a conception mode or in a cycle that includes conception. So if you look at the chart on the left, you will see that it is broken into two sections. It's not really clear, but right in here, this is where so it goes 0 to 28 days and then 0 to 28 days here. It also indicates the ovarian cycle right here, and that's the generation of the egg. Right here is the oocyte that is released into the fallopian tubes, and this is the corpus luteum here as it degenerates. Then on the cycle where a pregnancy does occur, where the egg resides, it gets fertilized and resides inside of the uterus on the wall, then we'll also see that the corpus luteum will not degenerate. It will continue to generate progesterone through the pregnancy to hold you from going into cycle again, and that way to protect the baby in the womb. Looking at the chart on the right, That's just a single cycle, right? Follicle phase and luteinal phase. And then what happens to your body is you have your basal temperature here, which is pretty close to 37 or 36.5-ish right here. See, that's 4, that's 2. So yeah, 36.5 right here, and then just under 36.7 degrees Celsius. So that is 96 to 98 degrees Fahrenheit. You're looking at your hormone levels, right? Your progesterone level during the follicle stage is low, and then after ovulation, then the corpus luteum, which has held the egg in place until the egg is released into the fallopian tubes. Then as it either deteriorates or as it holds the egg in place in the uterus, the progesterone will increase. And then if there's no pregnancy, then it will decrease. Okay. The estrogen levels, if we look at this gray line right here, start out lower and then increase right at ovulation, and then drop off, and then increase a little bit, and then drop off again. Right. And then the luteinizing hormone, which is in red, that comes in and then spikes to cause ovulation and then drops off. The follicle stimulating hormone is relatively high to its total contribution, and that is to stimulate the formation of the follicle into its maturing of the egg inside of the uterus. Right. And then one of the things that's missing here in the hormone level base is that the female's testosterone level will start out low, and then as ovulation nears, it's going to start going up, but it's going to peak right after ovulation, and then drop off. And this is to stimulate the desire for sex, so that there is a desire to copulate and to perpetuate the species, right? To get pregnant, okay? And that's what the testosterone level does. Okay. The ovulation occurs right around day 14 in your cycle. It's the rapid enlargement of the follicle and rupture of the foci, and with extrusion, which means that the oocyte leaves the ovary here and then flows out, and then is captured by the fingers of the fallopian tube and then pulled inside the fallopian tube, where it will either get fertilized or not fertilized. Some women can tell. There's sometimes that they get pain when they ovulate, or they get a discomfort when they ovulate, so they'll know that has occurred. Some women don't. The rise in estrogen and the mid-cycle surge of luteinizing hormone, and to a lesser degree, the follicle stimulating hormone occurs at ovulation. Immediately before ovulation, there is a drop in estrogen and an increase in progesterone. Okay, drop, increase. And the ovulation follows within 18 hours of the mid-cycle surge of luteinizing hormone. If not enough luteinizing hormone surge, then there is no ovulation. All right. Does anybody remember where luteinizing hormone and follicle stimulating hormone originate? All right, yeah. It goes back to keeping in mind, try to remember what we learned in the past, but you've got the pituitary gland. The gonadotropin hormone is released by the hypothalamus to the anterior pituitary gland. The pituitary gland then issues the instructions to the uterus and to the ovaries to work the cycle. And this is a monthly occurrence, and the pituitary gland releases the luteinizing hormone and the follicle stimulating hormone. So again, the hypothalamus up here, okay, will release the gonadotropin releasing hormone. It will go to the pituitary gland. Luteinizing hormone is then sent to the ovary, and the follicle stimulating hormone is sent to the ovary. Follicle stimulating hormone is for stimulating the follicles. The follicles are if you just think of the follicles as being the undeveloped eggs, okay? Each follicle is an egg, right? And the follicle stimulating hormone causes one or more of the eggs to develop more strongly than the next, and the strongest egg will then be released. The next cycle goes through. You go around this way, starts out here, get to the ovum. The ovum is collected into the fallopian tube, and then it starts splitting, and then fertilization occurs somewhere in this arena right here. The egg comes out and then embeds in the uterine lining, which is the endometrium. Endometrium, right in here. You have the estrogen is released during the process of the developing of the follicles, and then helps with the lining of the uterus, and the progesterone is developed during the corpus luteum time, which then holds the endometrium in place, just in case there's a pregnancy. If there's no pregnancy, then the corpus luteum will deteriorate, then progesterone won't be generated, and thus the menstrual cycle will progress, and the lining, the endometrium, would be expelled through the vagina. Now, the ovarian and menstrual cycles are tied together and yet are separate. They're tied together by the hormones, but they occur in two separate locations in your body. The ovarian cycle, of course, occurs within the ovaries, and the menstrual cycle occurs inside of the uterus. So the FSH and pituitary stimulates the granulosa cells, which then creates an increase in luteinizing hormone, an increase in the luteinizing hormone receptors and the follicle stimulating hormone receptors. So sensitivity goes up, and this prepares for ovulation. Okay, the growth of the egg and preparing for ovulation. Remember, the luteinizing hormone is all about the release of the egg into the fallopian tubes. At ovulation, your estrogen goes up, your luteinizing hormone surges, and then within that 18-hour time frame of the luteinizing hormone surge, you're going to have ovulation. During the luteal stage, that's after the ovulation, then the corpus luteum forms and will start generating the progesterone. The progesterone will then hold the uterine lining in place, which is the endometrium, until such time as there is a pregnancy or not a pregnancy. If there is no a signal from the uterus that there is a pregnancy, then the corpus luteum will deteriorate, the progesterone will stop being produced, and then you'll go into menstrual cycle. The menstrual cycle starts with menses. That is when the lining of the uterus is actually expelled from the body. Then you enter into proliferative stage. Once again, when the oocyte is, which is the egg, is released at ovulation, then you'll start generating the progesterone, which will then hold the lining in place, which is the signal that will come from the uterus to, or from the ovaries to the uterus to start generating the placenta in preparation for the egg being embedded, and then the lining in place at the end of the cycle. I wanted to point this out to make sure that we have a good discussion. Now, this is a very interesting slide. I understand that it is quite complex for many of you, but I did put this in here on purpose. And if you remember, Dr. Ladd McNamara wrote a book called The Cholesterol Conspiracy, where he basically says that all the people that are saying that cholesterol is bad are not telling you the whole story. And in fact, they are not telling you the whole story, because cholesterol is what's used to create the pregnenolone, which then is the formation of progesterone, and which is then transferred into your androgens and your testosterone, which is then turned into your estradiol and your estrogen. All right, so for your body to function properly, you need to have cholesterol. Now, cholesterol is only found in foods that come from animals. There is no cholesterol in foods that come from plants. None in fruit, none in vegetables, none in grains, none in seeds, none in nuts, none in beans, peas, or lentils. This is why God created us to be we need to be carnivores. Now, that's not to say that you can choose not to be a carnivore, but it is detrimental to your hormonal cycle. Okay. So if you're going to choose to be a vegetarian or a vegan, you're probably best off to wait until after you're in menopause, because you do need this cholesterol. Now, that doesn't mean you need too much cholesterol. Just like anything else, you need to take everything in moderation. But it is very important. Hopefully, you might have some questions about this later, but I wanted to make sure that you had an opportunity to see this and the correlation between cholesterol and your sex hormones. All right, so we have now come to the video portion of our presentation, and we have some really good videos. Now, we have, once again, too many videos to show in a reasonable amount of time. So what I've done for you, Mila, is that I put the ones that I want to show at the top, and then we'll let everybody else then take this slides, and then they can check out the secondary. So we want to start with that 9 minute and 54 second presentation. We'll go to the 7:42 and then to the 4:45. Okay, and then we'll do the 2:24.
Okay.
Is that okay with you? Everybody happy?
Yes.
All right, so let's get started on the video presentations.
Okay. Can you see my screen?
I can see your screen.
Okay.
I wanted to discuss the ovarian cycle, the uterine cycle, and each other, and the hormones involved in regulating these cycles. So I'd like to talk about the ovarian cycle first, and so that is shown in this box right here. You can see ovarian events. There are three main phases, and they're outlined here. The follicular phase right here, where you have growth of the follicles. Then you have ovulation, which is a one-day event. And following ovulation, you have the luteal phase. So during the follicular phase, you have growth of your follicles. So these not very developed follicles, your primordial follicles, will develop more into primary follicles. Some of your primary follicles will then develop into more secondary follicles. Secondary follicles are going to continue to grow. Some texts will just use large secondary follicles. This text says it turns into a tertiary follicle, but these follicles are going to continue to grow and grow. And this is under the direction of FSH, follicle stimulating hormone. And so, of course, the gonadotropin releasing hormone from the hypothalamus is going to cause FSH to be released from the anterior pituitary. So that increase in FSH is going to stimulate growth of your follicles. And you can see it tapers off after a little while. Inhibin is going to be released that inhibits FSH. But you do stimulate growth of the follicles during the follicular phase. And during each month, there will be one follicle that will outgrow all of the others. So you have a mature or Graafian follicle. And this follicle will ovulate. So that means the egg, the oocyte, is going to burst out of this follicle. During ovulation, the reason that ovulation occurs is because of a spike in this hormone, LH, luteinizing hormone. You see this big spike right here. That occurs right before this line right here, which lines up with ovulation. It takes place in about day 14 of a 28-day cycle. So the egg, the oocyte, is released from the follicle, and now this oocyte is going to head down the fallopian tube toward potential fertilization. Now we're not done with the follicle yet. This follicle will turn into the corpus luteum, and the corpus luteum is kind of like a little miniature endocrine gland. It is going to be responsible for the production of estrogen and progesterone. And you can see if we look down at this graph below very briefly, you can see progesterone, estradiol, these hormones increase when you have the corpus luteum made. So again, the oocyte, the egg, is headed down the fallopian tube. Corpus luteum remains inside the ovary. Now the corpus luteum is going to hang out for about 2 weeks or so, producing hormones. And if you have a fertilized egg, then it'll actually hang around for longer. It will continue to produce those hormones until the placenta is up and running, it takes about 3 months. If there's no fertilized egg, then this corpus luteum degenerates. So that involution, you have reduced growth of the corpus luteum. It disintegrates into the corpus albicans. At this point, the corpus albicans is not producing any hormones, and it's about done. You can see up here, we're starting to see a little bit of an increase in FSH again, this blue line, and these new primordial follicles are going to start turning into primary follicles. So this cycle, we're going to go right back to the beginning again. Primordial follicles can develop into primary follicles, some primary follicles into secondary follicles. So this increase in FSH stimulates follicular growth. So follicles continue to grow at ovulation, which is due to a spike in luteinizing hormone. This egg is released. The follicle turns into the corpus luteum, which secretes progesterone and estrogen. And after 2 weeks, if there's no fertilization that occurs, the corpus luteum will degenerate into the corpus albicans. And you continue to repeat the events in this cycle. Now, the corpus luteum can be saved from degeneration, and that is due to the presence of human chorionic gonadotropin. So if HCG is being secreted by this egg that was fertilized, then HCG is going to save the corpus luteum from disintegration. In addition to the events happening in the ovaries, you also have events that are happening in the uterus. So the uterine cycle, and pictured down here on this bottom row, the uterine cycle lines up well with the ovarian cycle. And this is so that the uterus is ready in case there is a fertilized egg. And there are several phases to the uterine cycle. You can see down here the menstrual phase, so that's when menstruation occurs or a woman's period. Then you have the proliferative phase. You can see a lot of growth happens here. And then the secretory phase. You have continued growth, and there's also a very good vasculature that happens here. You have very good blood vessels, and you're secreting even more of this endometrium. If there's no fertilized egg, then this lining is going to slough off, and again, you're going to start the whole cycle again the next month. So 3 main phases to the uterine cycle. You have the menstrual phase, the proliferative phase, and the secretory phase. So you can see during growth of the follicles, that is when the menstrual phase occurs, and then you're going to start proliferating. So this blue line here at the bottom is the stratum basalis, or the basal layer of the endometrium. It is always there. So the lining that sloughs off is this more purple area right here. That's the stratum functionalis, or the functional layer, and it is what grows and grows and grows and then is sloughed off. So you always have this stratum basalis. You grow and then slough off the stratum functionalis every month. So while these follicles are growing up here during the ovarian cycle, you are finishing up your menstrual cycle and you start to proliferate that endometrium, make a nice thick home for a potential fertilized egg to implant. At ovulation, you have already quite thickened your endometrium, but ovulation, it's still going to take about another 6 or so days for a blastocyst, which is the fertilized egg, and then the proliferation that occurs, the mitosis that occurs, that ball of cells. By the time it reaches the uterus, you're looking at somewhere around here. So that fertilized egg will reach the uterus and be ready to implant the uterine lining somewhere around day 21. And notice that the uterine lining is at its thickest during that time. The reason that you have this increased thickness right here is thanks to progesterone, which is going to be released by the corpus luteum. Corpus luteum will release progesterone and estradiol, and progesterone especially is going to be responsible for all the blood vessels and the increased secretion of the stratum functionalis. So progesterone, an especially important secretion from the corpus luteum. Estradiol is also being made. These together are going to help to maintain the secretion of that stratum functionalis. If you have a fertilized egg, again, HCG, that human chorionic gonadotropin, rescues the corpus luteum from degeneration, and you're going to maintain these hormones. As long as you maintain these hormones, especially progesterone, you'll maintain the lining, you maintain that nice, thick, happy, cushy home for the developing embryo. If there is no fertilized egg, if there's no blastocyst that implants, corpus luteum degenerates within about 2 weeks. As that corpus luteum degenerates, progesterone levels die off. You can see they decrease pretty sharply right here as you have involution of that corpus luteum. If progesterone is gone, also that stratum functionalis is going to go too. Progesterone is needed to maintain that lining. So if progesterone decreases, that lining is going to start sloughing off. So you can see all of the cycles are very closely related. What's going on in the ovarian cycle, the presence of the corpus luteum, the hormones that it secretes, when it stops secreting those hormones, this has a direct tie into the lining of the uterus. And this is very important because when you have a blastocyst that results from the fertilized egg, you want it to have a nice thick home for it to implant in. If this lining is not maintained, you're not going to be able to grow that blastocyst. So these are how all of your events line up in the ovarian cycle and the uterine cycle.
All right. So
Hello, welcome to Bite
hang on a minute, Mila. So
Size Med. Video is on the uterine or the endometrium.
going back to that whole cycle, as you increase your progesterone, one of the other things that's happening in your body is that the progesterone is preparing your breasts for milk production. So you're going to have a bit tender breasts. You're going to have increased sensation, and that's when your breast will start preparing itself for milk production. In addition to that, if you're in menopause, you begin menopause, sometimes the doctors will prescribe progesterone cream in order to help simulate a normal cycle. So they give you some estrogen and some progesterone to occur simultaneously to try to continue on and the cycle, so you don't suffer through the menopause outcomes. Is that right, Thecla? You wouldn't know. Okay. Anyway, so this is one of the components of it too. Is if you're looking to increase your breast size, you're going to want to stimulate your estrogen and your progesterone in the similar way as the cycle occurs. All right. Next slide. Next presentation.
Begin with the ovarian cycle. With the ovarian cycle, the follicular phase is taking place from menstruation to ovulation, which is from day 1 to day 14. The luteal phase occurs from days 14 to days 28. This is from ovulation to right before menstruation. You're going to need to remember that the ovarian cycle includes the follicular and the luteal phases. So if you think about this, the abbreviations are OFL. It's the ovarian follicular luteal phase, okay? For the ovarian cycle, this diagram is going to be very important, and you want to have this diagram set aside while we're going through the next slide. So dealing with the ovarian cycle, we're working with the ovary and what's happening or what's occurring in the ovary with the development of the ovum. And so the numbers on this diagram that are inside this ovary, 1, 2, 3, 4, and so on, correspond to the numbers on your next slide. When you look at this flow chart, there are numbers within the flow chart, and those numbers correspond to the numbers that you see here on this chart, as well as the numbers on the previous slide. And that way you can link this information together. Since we're working on the menstrual cycle in general, okay, that's the big picture, and we've got the two cycles, we've got a uterine cycle and we have an ovarian cycle. So when is all this occurring? When does this start in a female's life? Think back to the slide on oogenesis. So in oogenesis, there were 3 phases. There was the fetal development, there was ovulation, and after fertilization. So what you should realize is that we are beginning here at puberty. So this menstrual cycle is what starts to occur at puberty. So at puberty, are we dealing with a primary oocyte or a secondary oocyte, or an oogonia, what are we starting with if we're beginning this at puberty? So you should say that we're beginning with a primary oocyte, because remember, in fetal development, you have the development of, or meiosis 1 begins, but it's arrested once the primary oocyte develops. And so that meiotic period that's arrested starts again at puberty. So this primary oocyte is what we will begin with at puberty. So let's go through the ovarian cycle first. So once again, this includes the follicular and the luteal phases. We're going to start with the first phase, which is the follicular phase. So we begin with follicles. Remember, a follicle contains a developing ovum. So the follicle is going to be in this phase called the primordial follicle. And that's listed as number 1 on your diagram. The whole thing is called a primordial follicle. The developing ovum inside is called the primary oocyte. Now, the follicular phase on this primordial follicle, or the follicular cells, are located on the outside of the primordial follicle. So these are the follicular cells. The follicular cells start to develop around this oocyte, and you can see them around that primary oocyte. Those follicular cells are then going to differentiate into another type of cell called granulosa cells. Once that primordial follicle has those granulosa cells, we're going to change the name of the follicle. The follicle is now going to be called a primary follicle. So this is what you're seeing in number 2. The oocyte is still a primary oocyte. Now, the stage of development then is called a preantral stage of development. Once we have those granulosa cells, they're going to secrete what's called the zona pellucida. Your granulosa cells will develop into the zona pellucida. Now, the zona pellucida is going to differentiate to form what are called the theca cells. So now we have these theca cells. Now, some of these cells don't go beyond development any longer. Now, remember, this is happening at puberty, so we're talking about a primary oocyte, right, per month that's going through this development. Some of your follicles will continue developing and form a fluid-filled cavity called the antrum. So this is now called a secondary follicle, and it's also called an early antral follicle or the early antral stage. Some follicles don't develop beyond this stage either. When the follicle is either preantral or early antral, one of them is selected to develop to maturity. The follicle that's selected to develop to maturity is called a dominant follicle. Development continues, and now what we have is what's called a late antral stage or a late antral follicle. And that antrum, look at how much larger it is now in this diagram, much larger. So it's continued to grow. Some of the granulosa cells of this layer will form the corona radiata. So that's sort of this rough-looking layer here that surrounds that primary oocyte. Then there's also the cumulus oophorus. And now, after all of this happens, we have what's called a Graafian follicle. All right, once the Graafian follicle has formed, meiosis 1 is completed. Remember in the slide on oogenesis, when meiosis 1 was completed, you were left with a secondary oocyte. So we're no longer dealing with the primary oocyte, now we're dealing with a secondary oocyte. The secondary oocyte is going to be floating freely in the antrum. All right, so you can see from this diagram where the primary oocyte was, it moves in the antrum. This is now a secondary oocyte that's floating freely. Now we're starting the luteal phase. That's the last phase of the ovarian cycle. So the Graafian follicle ruptures. So if we move this up just a little bit here, you can see how the follicle is rupturing. So here's our secondary oocyte, and here's what's left over. This is the entire thing would be called the follicle. All right, so when that ruptures, the secondary oocyte enters the uterine tube. Remember, it's always the secondary oocyte that enters the uterine tube. All right, now what's left to the follicle, the rest of the follicle? So that gets transformed into what's called the corpus luteum. So that corpus luteum is going to secrete estrogen and progesterone, which we're going to talk about more later, but always keep in mind, corpus luteum secretes estrogen and progesterone. If the oocyte is not fertilized, the corpus luteum will degenerate and you're left with what's called the corpus albicans. Because you don't have the corpus luteum, the levels of estrogen and progesterone then are going to decrease, and then that sets the stage for the follicular phase to occur all over again in the following month.
One of the things to take away from this is a reinforcement of the cycle, but also some terminology differences were used during this presentation than were used during my presentation and the previous presentations and the subsequent presentations. One, they didn't call the menstrual cycle, they called the menstrual cycle both the ovarian cycle and the uterine cycle. Well, that is only in a small portion of the medical community do that. Generally speaking, the menses is menstrual cycle. So when the period is associated with the menstrual cycle. The other one was to call the fallopian tube the uterine tube. That takes place in a small amount of texts and presentations, medical presentations. So I don't want there to be a confusion. The uterine tube and the fallopian tube are the same thing. And the uterine cycle is the menstrual cycle. Okay.
Ovulating. Are you planning to bring to your family? Have your partner and you've been trying to conceive yet have not been successful? Understanding your ovulation cycle will definitely help your chances of getting pregnant. Your chances of getting pregnant increase when you have sex in the 3 days leading up to and including your ovulation cycle. Read on to now or more to know when you are ovulating and ways to know your ovulation days. What is ovulation? Ovulation is one of the most fertile periods in your monthly cycle. This is a small time frame each month, usually for about 12 to 24 hours. During this time, you release an egg from your ovary, which are at their best chance of getting fertilized. Once your ovary releases the egg, it travels down the fallopian tube and is ready to fertilize. If the egg doesn't meet the maximum, it gets absorbed by the uterus. The egg is then expelled out of your body during your menstrual cycle. How to know when you are ovulating? Here are a few ways in which you can understand when you are ovulating. This will help you to plan your pregnancy better and help you avoid getting pregnant. There are a few different ways that can help you check your ovulation days. Method number 1. Check your basal body temperature. Basal body temperature is your body's lowest temperature in the span of 24 hours. Before ovulation, your basal body temperature will be around 97.2 degree Fahrenheit to 97.7 degree Fahrenheit. Your basal body temperature will increase about 0.4 degree to 1 degree 2 or 3 days after your ovulation. The increase in basal body temperature is a good indicator that you have been ovulated. You can easily buy a basal body temperature at your local drugstore. This can come with a chart that will help you to track the temperature for multiple months. Use the thermometer while you are still in bed every morning. Note the reading in the chart. For best results, take the temperature time each day. Look out for the prolonged increase in basal body temperature. This should usually last for a few days. This increase in indication that you have started ovulating. Once you understand the pattern, you will know instantly when you are ovulating. You will be ovulating 2 or 3 days before your basal body temperature takes a hike. You can also take this temperature vaginally. It is important to follow the same method of taking the temperature each day. Method 2. Check your cervical mucus. You can also do a test by wiping your vagina with a toilet paper and checking it. Alternatively, you can insert your finger in the vagina and try and brush your cervix. This mucus will transfer to your finger 2 or 5 days after your menstrual period. Your genitalia will be extremely dry. Post this, do you notice a consistency and that of sticky rice in your cervical mucus? Just before during ovulation, your mucus will be at the fertile peak. What is cervical mucus means your mucus is fertile. Cervical mucus that has a consistency like egg whites is highly fertile. Check your mucus each morning when you take your temperature. Record the consistency in the chart. Method 3. Ovulation kits. You can use a home ovulation kit that can easily be purchased from the drugstore. It measures from luteinizing hormone content in the urine. High amount of luteinizing hormone content means you are about to or are ovulating. Start using the kit 5 to 7 days before you think you will ovulate. You should test for the luteinizing hormone during the later in the morning or early afternoon. Read the instructions carefully. A positive result is when the result lines in darker rather than the control line. This proves that you are mostly likely ovulating. Use the kit in combination with or other ovulation test methods. Method 4. Check using the calendar. The last day of your menstrual period will be the beginning of your next period. Ovulation will happen midway of the cycle, either on your neither 14th day or your period may be regular but still be shorter or longer. If you are trying to conceive, the best time is a few days before you actually start ovulating till a few days after ovulation. This will store and work even your period gets irregular.
That's interesting.
Next one, Mila.
Next one. Fertilizing.
While Mila's doing that, I'll explain this. This is a basic tiny humidifier in which you place your USANA.
One question I get is how to play up your eye.
All right, there we go. Your essential oils go in there and it vaporizes. It's a little bit better than trying to cause them to be heated up and then atomized into the atmosphere through heat. And it's just kind of oppressive here today.
No wonder you have that side effect, right? But I wonder where that comes from.
All right.
Fertilizer is the epic story of a single sperm facing incredible odds to unite with an egg and form a new human life. It is the story of all of us. During sexual intercourse, about 300 million sperm enter the vagina. Soon afterward, millions of them will either flow out of the vagina or die in its acidic environment. However, many survive because of the protective elements provided in the fluid surrounding them. Next, the sperm must pass through the cervix, an opening into the uterus. Usually, it remains tightly closed, but here the cervix is open for a few days while the woman ovulates. The sperm swim through the cervical mucus, which is thinned to a more watery consistency for easier passage. Once inside the cervix, the sperm continues swimming toward the uterus, though millions will die trying to make it through the mucus. Some sperm remain behind, caught in the folds of the cervix, but they may later continue the journey as a backup to the first group. Inside the uterus, muscular uterine contractions assist the sperm on their journey toward the egg. However, resident cells from the woman's immune system, mistaking the sperm for foreign invaders, destroy thousands more. Next, half the sperm head for the empty fallopian tube, while the other half swim toward the tube containing the unfertilized egg. Now, only a few thousand remain. Inside the fallopian tube, tiny cilia push the egg toward the uterus. To continue, the sperm must surge against this motion to reach the egg. Some sperm get trapped in the cilia and die. During this part of the journey, chemicals in the reproductive tract cause the membranes covering the heads of the sperm to change. As a result, the sperm become hyperactive, swimming harder and faster toward their destination. At long last, the sperm reach the egg. Only a few dozen of the original 300 million sperm remain. The egg is covered with a layer of cells called the corona radiata. The sperm must push through this layer to reach the outer layer of the egg, the zona pellucida. When sperm reach the zona pellucida, they attach to specialized sperm receptors on the surface, which triggers their acrosomes to release digestive enzymes, enabling the sperm to burrow into the layer. Inside the zona pellucida is a narrow, fluid-filled space just outside the egg cell membrane. The first sperm to make contact will fertilize the egg. After a perilous journey and against incredible odds, a single sperm attaches to the egg cell membrane. Within a few minutes, their outer membranes fuse and the egg pulls the sperm inside. This event causes changes in the egg membrane that prevent other sperm from attaching to it. Next, the egg releases chemicals that push other sperm away from the egg and create an impenetrable fertilization membrane. As the reaction spreads outward, the zona pellucida hardens, trapping any sperm unlucky enough to be caught inside. Outside the egg, sperm are no longer able to attach to the zona pellucida. Meanwhile, inside the egg, the tightly packed male genetic material spreads out. A new membrane forms around the genetic material, creating the male pronucleus. Inside, the genetic material reforms into 23 chromosomes. The female genetic material, awakened by the fusion of the sperm with the egg, finishes dividing, resulting in the female pronucleus, which also contains 23 chromosomes. As the male and female pronuclei form, spiderweb-like threads, called microtubules, pull them toward each other. The two sets of chromosomes join together, completing the process of fertilization. At this moment, a unique genetic code arises, instantly determining gender, hair color, eye color, and hundreds of other characteristics. This new single cell, the zygote, is the beginning of a new human being. And now the cilia in the fallopian tube gently sweep the zygote toward the uterus, where he or she will implant in the rich uterine lining, growing and maturing for the next 9 months until ready for birth.
Right.
So cool.
Yeah. Let's talk about the success of the fittest, or fighting against all odds, or the uphill battle, and you figure that 20 to 30 million sperm, and only one reaches the egg.
And the one who's swim the fastest, right?
Well, not necessarily, because there's another presentation that talks about the initial one breaking the way open for another one to get in. So one might be dispelled trying to fight to get in, but it opens up a pathway for another one to get in rather than itself. Okay, so it's not the fastest. It tends to be the one who is more persistent. Okay, next one, Mila.
Cervix, the uterus, the uterine tube, and at the end we've got those fimbriae. We also have the ovary with oocytes or eggs inside. Now the brain is important in this process of the menstrual cycle because underneath it there's the hypothalamus, and underneath that is the pituitary gland, and we're focusing on the anterior aspect of the pituitary gland. Now we've got day 0, 14 and 28 that we're going to focus on with this reproductive cycle. So first thing is primordial oocytes or eggs undergo this process of maturation where they turn into primary follicles, secondary follicles and tertiary follicles. As this happens, certain cells become apparent and abundant. For example, follicular cells in the primary follicles then turn into granular and theca cells. They become more abundant, and then by the time it's a tertiary follicle, you've got huge amounts of granular and thecal cells. Now these tertiary cells or follicles, most will undergo atresia or cell death, but if early on in this cycle, the hypothalamus releases gonadotropin releasing hormone, and that travels to the anterior aspect of the pituitary, that will release gonadotropins. There's two, follicle stimulating hormone and luteinizing hormone. Here we're focusing on FSH. That surges, so you get this little spike of FSH. That travels to these tertiary follicles and selects some to stop undergoing atresia and mature into a Graafian follicle. So one will become a Graafian follicle or mature follicle. You can see the granular and theca cells become quite abundant and they release estrogen. Now this estrogen continues to prepare the uterine lining for implantation, and its low levels, because you can see it's starting to bump up here, and the low levels of estrogen inhibit gonadotropin releasing hormone from being released. But as the Graafian follicle matures, it starts to release more estrogen, and the high levels of estrogen not only continue to prepare the uterus, but it activates gonadotropin releasing hormone, and you get a surge of FSH and LH just before day 14. Now the LH, luteinizing hormone, travels to the Graafian follicle, tells it to ovulate at around about day 14, and the fimbriae take in that egg into the uterine tube. What we're left with is this empty body called the corpus luteum, which means yellow body. It's yellow because it's mainly cholesterol, and it releases progesterone for around about 10 days. So you can see that here. The progesterone further prepares that uterine lining for implantation. But if at the end of this cycle, no egg is implanted, no signal is sent, the uterine lining sloughs away, and that's menstruation.
All right, really quick there. One of the things about menopause and looking at what goes on in terms of menopause, and we think about the cycle, we know that women are born with all of the eggs that they will ever have, and they will release these eggs in every cycle. And doing that process, there are the release of 30 or 40 or more eggs during the cycle, and all but one or maybe two if you're having twins or so forth, then will then ovulate. Now the difference in twins, of course, is if you have two separate eggs or if you have one egg that splits. Okay, and so that's the issue with twins. But the fact of the matter is, going back to it, is that when menopause occurs, the changes in the hormonal signals change based upon the number of follicles, that is eggs, that remain in the woman's body. So as the amount of eggs decrease over the lifetime, there is less signals that go back to the hypothalamus, right, to send the gonadotropin releasing hormone to the pituitary gland, which then generates the LH and the FSH. Okay, so the signal coming from the ovary back up to the hypothalamus is weaker, and therefore there wouldn't be as many signals to cause you to go into cycle. And therefore, if you think about it, your bank of eggs determines when you go into menopause. Does that make sense? Anybody, shake head, yes, no? Does it make sense? Yeah. So you could start out with 1, 2 to 30 million eggs. And then over your lifetime, they would then decrease every month all the way down. And as you have less eggs, you're going to have less, the follicles give off the estrogen, which tends to signal up. And then you've got inhibin, and you've got these other hormones that tell the hypothalamus to or not to generate the luteinizing hormone and the follicle stimulating hormone. And therefore you stop having a cycle. And when you stop having a cycle, you're at the same time, you're generating less hormones, because you're not generating hormones in your luteinizing, in your corpus luteum, and you're certainly not generating your estrogen during the follicle development. There's no follicles to develop. All right. I know that didn't appear to translate on my screen, and I was hoping that it would, Mila, but I don't know why my screen's not translating into Chinese without being in the presentation. Maybe we could get back into the presentation and I can get that same discussion.
Right. You can share your screen to see if it can translate.
All right. All right. We're going to see if this translates. So what I was leading up to is we have a conversation about menopause and about what it is that creates the relationship between menopause and why some women go through menopause early, why some women go through menopause late. And the theory is that a woman is born with all the eggs that she's ever going to have. And these eggs basically in their primordial stage are called follicles. And the egg is actually, the ovum is actually inside of the follicle. But that being said, you have all that you're going to have. And then every time you menstruate, every time you ovulate, you're going to be losing eggs. And you're not just losing one egg, you're losing tens of eggs. And depends upon the woman as to how many eggs she loses during the process. And we heard them talk about some of these cells, they don't generate, and they slough away, or they disintegrate. And then only the strongest follicle is ovulated. Well, at the same time, you've got these other follicles that have generated along with it, and then they go away. So you're losing more than one follicle or one egg every time you ovulate. So you start out with million or so eggs in your ovary, and then as time goes on, you're going to have less and less. And at some point in time, the hormonal signal that leaves the ovary, which sends well, let's just call it the body count, the number of eggs, back up to the hypothalamus, which then would generate the gonadotropin releasing hormone. Then you're going to get the LH and the FSH, the luteinizing hormone and the follicle stimulating hormone, released from the pituitary gland to the ovary to cause the cycle, the ovarian cycle, to progress. If you don't have the eggs to start with, you're not going to get the signals out of the hypothalamus to the pituitary to the ovary to cause the development of those eggs. And you're going to have less estrogen. You're going to not be generating the progesterone inside of the ovary. You're going to be generating some in other glands, as we talked about before. But inside of the ovary, you're not going to be generating these, and that's where you generate most of them. So you're going to have a decline in hormones, and you're also going to have a decline are interruption in the number of cycles, right? You're not going to have a regular cycle, and you're not going, and your number of cycles is going to go away, right? This all deals with the bank of eggs is now depleted, and now you don't need a cycle because the egg base is no longer there. And this is the theory of when women go into menopause. Depends upon the level or the number of eggs remaining in their ovaries. Okay, that being said, do we have one more movie, Mila? Or was that it?
That's it, I think. I think the top video in this.
Okay, so what we'll do now is we'll go on to the next slide. Next slide. There we go. Okay. And what we want to do is to reiterate the fact that nutrition and behavioral health are linked. Okay. Now, nutrition and hormonal health are not linked because there aren't the studies to prove that they're linked. However, the linkage of the behavioral health indicates that there are ties between the quality of your nutrition and your behavior depends an awful lot on your hormones. So we can interpolate the fact that if you have great nutrition, you're going to have a much better or balanced approach to life, and then you're going to have balanced and more regular hormonal operations in your body, and that your endocrine system will be working to its fullest. Now, I put that red down in here, basically that says, and I'll reiterate, no amount of great nutrition is ever going to fix stupid. And that's not a question. That is a statement. It is true that you can overcome the best nutrition in the world by doing stupid things, like eating poorly is a stupid thing. And you have a choice as to how you approach your diet and your life. And in so doing, one of the best and the most important things is to eliminate the things that hurt you and then increase the things that benefit you. So going back into this conversation is that we can tie great nutrition to behavioral health and to the health of our hormones through that behavior, but all that's obsolete or insignificant compared to, say, smoking, eating lots and lots of fatty foods, bad things like processed chips and corn and those sorts of things you want to avoid. You want to, if you're going to have oils, you're going to want to have the very best healthy oils, and choose your food wisely and choose your activities wisely. And please follow me on steps on the WeChat. Every day I check on you to see how many steps that you've done. I've send out little hearts to let you know that I'm watching. And so activity level goes a long way towards your health and hormonal balance. Next slide. There we go. And so your nutritional deficiencies impair function, and optimum levels can resume or enhance your body functions. Your studies reveal that diet and nutrition are critical for physiology and body composition and have a significant effects on mood and mental well-being. Dietary habits are being researched with focus on relationships and mental health. So we're on a cutting edge talking about this right now and pulling down this. Now, what goes into the creation of estrogen? Well, golly gee whiz, it's everything that's inside of your health pack. So if you're interested in knowing how to maintain your estrogen levels throughout, to make sure that you've got everything that your body needs to create estrogen when it's in hormonal balance to do so, then you need to look at this and say, oh my gosh, I'm doing that because I'm taking my health pack. All right, so why we try to do this is because we started out talking about nutrition and relationships. And we talk about how that occurs in terms of how health and mood and feelings and behaviors and relationships and intimacy and sex and reproduction and the preservation of the human kind. And we needed to talk about hormones and the endocrine system in order to get there. And guess what? We have now completed the hormonal aspect of the endocrine system, and that we will now be going back into relationships. And that will be the subject of next week's presentation. Next class is the 26th of February, and we're going to talk about hormones and attraction in terms of creating the mood for reproduction. So I'm looking forward to seeing you all here. Get the word out so others can join us. And as we get into this, we'll be getting more intimate in our conversation because that is the nature of the discussions that we need to have. If this makes you feel uncomfortable, we can take these discussions offline. So hopefully you can send me a note, let me know what your preferences are in this regard, but we are going to get down and start talking about what it takes to create the right mood and how your body does this.
Thank you. I'm excited to learn more about next week.